Hello and welcome to this Modurol video about how to fit a magnetic gear position sensor to a Tremec T-56 Magnum gearbox. Now this is video MT27 in our series of XK videos detailing how we converted our automatic Jaguar XK to manual. And in our case we're using the manual gearbox that came out of an Aston Martin Vanquish. In order to ensure the car doesn't go into limp mode, we're using a manual control module as supplied by Glenn Neilson in the US, and he needs us to fit a magnetic position sensor, in particular this one, to the gearbox in order for that all to work. But this also applies to anybody who might have an Aston Martin Vanquish or use a T-56 gearbox and want a magnetic gear position sensor. And Aston Martin themselves had an upgrade from these coat hanger style gear position sensors to a magnetic one mounted on the top here. That part number was 1R12-41-10465, but unfortunately that's no longer available. It's not an option for anybody. So what we've done, we've actually developed a way of using an alternative, a ZF version that's actually used on the ZF S653 gearbox and lots of Land Rover Discoveries. Now this part number is TXM50040. There's also the magnetic position carrier, which is TXM50060. You'll also need an adapter plate, a shoulder bolt and a locking nut. It really is that simple, and it bolts straight on this position. So in this video we're going to show you how to modify this slightly and how to fit it into the gearbox. So to remove this plate on the top of the gearbox, you need a 13mm socket, and the screw should just undo, or the bolt, sorry. Then what you have a plate and a gasket. Put them to one side. Then you can see the gear position, or the gate sort of mechanism here. I've actually already put a bolt in there. You do, originally there was a 3/16 split pin in there, so I've knocked that out. I've actually put a 3/16 shoulder bolt in there temporarily, and that's what I'm going to use to bolt down the magnetic carrier. So I need to modify that, so that'll take that hole, basically drop that on the top and bolt it down. So the idea is to mount this magnetic carrier over the top there and use the same bolt hole. It should clear this side, but on the back, as we look here, this tab, actually the sort of neutral position lock will actually foul. So we're going to have to nibble a little bit away here in order for that to fit. The rough measurement then, sorry I need to put a new battery in this, but is about 13mm. So I'm going to have to remove 13mm off this edge here, from here to here. So I'm just going to nibble that away quietly and see how we get on. Just to confirm, the modification you need to make to the caliper carrier to clear this location pin for the manual position, or sorry, neutral position. So you need to cut away 13mm from this end to here and approximately 5.5mm up. You can see it's not parallel, but it's very rough, and then that should clear the this part of the casting here, which is the neutral pin location. So the next thing is the bolts. So there was a 3/16 split pin in there, so I've bought a 1 inch long 3/16 shoulder bolt to go in there. Just line up the hole. That goes in great. The only problem is there is a little bit of movement in there, which I'm not really happy about. So we need to sort that out, try and tighten that up a bit. Try and get a bit of shim in the hole together with the bolt to make it as tight as possible. And the other issue, obviously, on this magnetic carrier, there's actually a 4mm clearance hole in there, and 3/16 is actually doesn't go because that's 4.75. So I'm going to drill a 4.8mm hole through there, and then that should clear the shoulder bolt. We'll be able to have a look at it bolted up. Okay, so we're going to test fit this now we've modified it. So I've just put that bolt in there temporarily. So pop that out, drop that on, line up the hole at the top. Somewhere near. Okay, that's it. It's all sprung loaded because of the original sensors. Right. Okay, we're bolted on there. So that's in place. I'm not going to put the nut on just yet. You can see the thread. You can just see at the bottom there the thread all the way through. What we're going to do is going to try this with the sensor on. So we've made this adapter plate that sits on the original holes. So that's all tightened on, and then the sensor will mount directly over the top. Get it round the right way. There you go. There you go. We're in. And we're just going to put 2 temporary bolts in. Okay. So that's in the right position. So what I'm going to do now is I'm actually going to change gears and make sure I can get all the gears. First, second, third, fourth, fifth, sixth, reverse. Let's try it again with the top on. Make sure nothing fouls. First, second, third, fourth, fifth, sixth, reverse. Got all the gears, and this was all intact, so it's a big thumbs up. Okay, so a couple of jobs before we finish. Unfortunately, the bolts that come with the sensor aren't quite deep enough to get at my encapsulated nuts. So I'm going to have to get some slightly longer versions of these that will cover both this little insert bush and it's got to come over the plastic. Otherwise, if I just use the ordinary sort of cap screws, it'll cover the bush, but the plastic will just come off. So that's not good. I need something with a wide diameter head. But anyway, that's the small issue. I've got that. And if you're interested, this adapter plate is 15mm high, and the sensor is also 15mm high. So the overall height above the top of the gearbox is 30mm from top to bottom. So I'm not sure if that's a clearance issue to the car body above, but we'll see. It's not too bad. It's quite flush. If we take a look at from a distance, give you some idea on the gearbox how it looks. I say it is 30 millimeters high bolt holes, but hopefully that'll clear the car. If not, I might have to go back to try and fix it under here, which is also possible, but this seems quite a nice solution, so I'd rather stick with this if this fits in the car. We won't truly know if this is a good fix until I've programmed all the positions, but I think I've got every confidence this will work. We won't know until we've plugged in and programmed the positions. I want to talk a little bit about this adapter plate on top of a T-56 Magnum gearbox using these standard Land Rover magnetic sensors and magnetic carrier. So the way we've been able to do it, we developed it from a steel version. We started off with this, so we've took the bolting points, and originally I thought the sensor sat central to the selector shaft, which obviously it does sit central in the gearbox, but not. If you can see here, it's actually, the sensor needs to be over here somewhere. It's about 4 or 5 mil offset, so offset this way. So when I located the sensor on here, we've had to move the whole fixing of this over 45 mil towards the camera. So I gave up with the steel version. It seemed I needed a bit more height, and it was getting quite heavy and cumbersome and not easy to develop. So then we started with the 3D printing. So started off with this one, gives you an idea what we're looking at. So you can start to see the offset, and the idea was to have some nuts on the bottom, which the sensor bolted to, and the adapter plate bolted directly, which is what we've gone with. So that was the first one. Then we actually noticed we needed some extra offset. So you can see there we've actually moved it slightly further over and made it stronger. And as the magnetic carrier moves forwards and backwards, there is a chance of it fouling at the bottom here. So we started looking at cutting that away. I think you can see that there. I got that wrong then, because the cutaway isn't central, because the sensor is offset. So we came up with this sort of final version. You can see the captive nuts on this one, and you can see the offset of that cutaway. So that's sort of what we've gone with. You notice we're not using this one because the print didn't come out very well. A friend of mine, Josh, he's got a much better 3D printer. He printed this one. It's pro standard, really nice finish. If you're interested, these nuts can't fall into the gearbox because they're actually underneath here. It is the casting, so they're actually trapped between the adapter and the casting. See, if you see here, between these two bolt holes, there's actually cast aluminium of the gearbox. You can see here, it just passes over it. So there's no way these nuts can come loose and drop into your gearbox if you're interested. So that's how we've adapted the adapter plate. If you look from above, you can see it a bit more clearly. So this sensor, albeit it rotates centrally here, it is a little bit offset. The sensor drops straight over. Now the height, to check the height, Glenn was talking about a 2mm gap, bit of rubber. So we've got some 2mm thick rubber. So I'll just drop that on top and make sure I can put the sensor back on, and that will assure us we've got a 2mm gap. Yeah, it's slightly tight. I'm gonna fit this gasket underneath. So if you're interested in sealing, I'm gonna put the gasket underneath so the adapter's sealed at the bottom, and also there's an O-ring on the actual sensor itself, so nothing can pass through here. So by the time I've got my gasket under and the sensor on top, the spacing's going to be pretty good. So just give you an idea of the difference in quality of prints from my printer. This was mine, of my 3D printer. It's okay, but struggling. And then you got the one that Josh gave me, and this is just another level. Absolutely awesome. I think I'm buying this printer just on this result. Josh has given me some advice how to improve this, so I'm going to try that first. This was printed on an Ender 3 V2, but I think I can get better at that. And I think Josh's was printed on, I can't remember. I'll put a picture up now to show you. Printer times, and my print took 12 hours. Josh's took 2 hours. So that's, you can see this is proper 3D printing, and this is just playing at it. Okay then, that's the theory of how we fitted it. I mean, I'm hoping it'll work. I haven't actually tested it. I've still got to connect it all up and get the gear positions calibrated in relation to the magnets to the sensor. But I'm pretty sure it worked. The actual connector here is 6-pin, and the two old style are 3 and 3. So I'm pretty sure we can get that all to work. So next then, what are we going to look at? Well, actually, if I move over this way, I've got a few issues with the selector I'd like to sort out. I don't know if you can see here, the selector mounting block is actually at a strange angle to the gearbox mounting bracket here, and the gear stick is, as I said before on a previous video, is leaning backwards a bit. So what I'm going to do, I'm going to actually modify or make a new shaft, slightly longer. Oh, while I'm thinking about it, yeah, the gear lever should be 37 inches from the front of the bell housing, and unfortunately on mine it's actually, I think it's 34.5 inch. So we'll actually move the whole thing back to make it come out into the center console in the right position. The other thing I'd like to do is this universal joint. I'd like to bring the whole thing flat and take this universal joint out, which has some scope for a bit of wear and slop in there. So I might actually either replace it with a new one or just make it a straight, take the joint out, make the whole shaft, just to extend it, and therefore get a positive gear selection. Hopefully that's of interest if you've got an Aston Martin or a Tremec gearbox and you want to fit a magnetic position sensor. It's fairly easy to do. If you want the CAD data to 3D print your own adapter, please email the channel and I'll tell you where you can find it on our website. Anyway, thank you very much for watching. Please like, comment, share and subscribe for more XK videos. Bye bye.